Good morning, students. As we have discussed earlier in the video about the friendly casotherm, he plotted a graph between amount of adsorption and pressure. So, uh, as we discussed, when the pressure increases, the amount of adsorbent also increases. Amount of adsorbent also increase. So he divided in three parts: low pressure, moderate pressure region and high pressure region. In low pressure region, the value of 1 by n equal to 1, and he proposed as amount of adsorption is directly proportional to the pressure. And he at low pressure the value of 1 by n equal to 1 by n equal to 1. So he found at low pressure region, at the pressure increases, the value of x by m means amount of adsorption also increases. In this way he plotted a graph. So he showed by this graph, as the pressure increases, amount of adsorbent of amount of adsorption also increases. Let's see in the moderate region what happens. So in the moderate region, means about this particular region. So in the next, at the moderate region, the value of moderate pressure region. So in the moderate pressure region, the value of 1 by n is greater than 0 but less than 1. So he found that, like, because in moderate region, as the pressure increases, the amount of adsorption also increases. In that case, directly proportional to the P graph, P to the power 1 by n. So he found curve like graph. So no changes takes place. Let's come at the high pressure region. So in the third case, in high pressure region. In high pressure region, x by m in high pressure region, x by m is independent of pressure. So friendly isotherm is not valid at high pressure, as this is exactly proportional to pressure and it comes to the power 0, means 1 by n equal to 0. So friendly casotherm is not valid at high pressure, because whatever the pressure will be, or the pressure increases, there is a straight graph obtained. This shows that at high pressure further no adsorption takes place. So let's write about this friendly casotherm. Is not valid at high pressure, not valid at high pressure. So friendly perform an experiment. So by this equation, x by m k pressure to the power n. So friendly perform experiment by changing the pressure and noted down the amount of gas adsorbed on the solid. On this experiment, on the basis of this experiment, he plotted a graph. So by this equation, by using log on both side, so log x by m, log k, and 1 by n log p. So by using log, he make a equation log x by m, log k, log 1 by n log p, or by writing this 1 by n log p plus log k. So it comes y, straight line graph, y equal to m mx plus c. So by on the basis of this, he plotted a graph. So like this, x by m and log x by m, and log p. So intercept c. So this graph form like this, and here is the intercept, it is log k, and this is the slope, which is equal to 1 by n. So he plotted a graph like this. At different temperature, this isotherm generally we use to explain this isotherm we use generally to explain physical adsorption. So friendly isotherm is mostly for physical adsorption. So the graph plotted between x by m and pressure at constant pressure at different temperature. So 1, 2 and 3. Suppose this is T1, T2 and T3. So T3 is greater than T2 and T2 is greater than T1. As the amount of adsorption will decrease with increase in temperature for absorption. So as the amount of absorption will decrease with increase in temperature. Temperature increases, so amount of absorption decreases. So let's discuss the dependence on the temperature. Dependence on temperature. Physics option. Physics option decrease with increase in temperature, as we already discussed about the as Wonder Wall forces break, so that physics option decreases. So at constant pressure, we find a graph like this, x by m and temperature. So it look like this. So physics option decreases, amount of absorption decreases with increase in temperature, because weak van der Waals force exists in this particular, so it breaks as the temperature increases. In case of Chemis option, first increase with increase in temperature, as initially when temperature is increase, the energy is absorbed, contribute for activation energy, and rate of adsorption increases. As adsorption is endothermic, so x by m value decreases after certain temperature. If we plot a graph by explaining it, so x by m versus temperature, so it first increases and then decreases. So at this particular point, temperature at this point first increases to contributes energy for activation energy, and after that it x by m value decreases. So this is the dependence on temperature for physics option and Chemis option. So in the next topic, our next topic is the factors affecting the absorption of gases by solid. We have already discussed about the periodic isotherm. We have already discussed about this particular. So next we will discuss about the colloidal solution. So we will discuss about the colloidal solution. Good morning, students. In the surface chemistry chapter, we will already discuss about the different properties given in your surface chemistry chapter. Today we will discuss the next topic of this particular chapter, that is colloidal and colloids and colloidal solution. So let's we discuss what is colloids and colloidal solution. So surface chemistry, video number 3 and 3920, class 12. So students, what is colloids and colloidal solution? For this, at first we distinguish the different solution like true solution, colloidal and suspension on the basis of their property, means particle size. So let's we define the colloids first. When the size of the particle lies between 10 to the power minus 9 to 10 to the power minus 6 m, means 1 to 1000 nm, it behaves like colloids. And what is colloidal solution? What is colloidal solution? So today's topic, in this session I am going to discuss the colloids and colloidal solution and their properties. So at first, what is colloidal solution? It is the heterogeneous system in which particles of one to 1000 nm size as dispersed phase and distributed in the dispersion medium. So at first we discuss about the difference between true solution, colloidal and suspension. So let's see the difference on the basis of difference in the size of particle. So true solution, colloidal solution and suspension. True solution, colloidals, colloidal solution and suspension. So at first we discuss about the particle size. The true solution, the particle size is less than 1 nm. In the colloid, 1 nm to 1000 nm. In suspension is 1000, greater than 1000 nm. Next discussion is on the basis of nature of the solution. It is the homogeneous in nature, because the size of particle is very small and it looks like a homogeneous, but actually it is heterogeneous in nature. Heterogeneous in nature, and it is clearly heterogeneous in nature. Next, on the basis of visibility. On the basis of visibility, particles are in the true solution. Particles are not visible, even under microscope. Visible under microscope in case of particles of colloidal. Visible under microscope. But the particles of suspension visible with naked eye. We can see with the naked eye. Visible with naked eye. If we talk about on the basis of filtration, so the size of particles of true solution is very small, so simply it can't be filtered, but can be filtered in case of colloidal solution, can be filtered by membrane, filtered by normal filter paper in case of suspensions particle, filter by normal filter paper. In case of settling under gravity, particles settling under gravity, we differentiate the different solution on the basis of particles character. So settling under gravity, the solution to solution particles not settled, don't settle under in case of colloidal solution, do not settle under gravity but are settled by centrifugation, process. In case of particles of suspension, settles under gravity. So on the basis of difference, the characteristic of a particle, we can easily distinguish or see that what is the size of particles of true solution, colloidals and suspension, and other characters of the particles also. Let's we discuss the on the basis of the definitions of colloids. So colloids are heterogeneous heterogeneous mixture in which very fine in which very fine particles 1 nm to 1000 nm of a substance which is dispersed phase are dispersed into are dispersed dispersed into another substance which is called dispersion medium. Dispersion medium. So this is the simple definition about the colloids. What is colloidal solution? So what is dispersed phase and dispersion medium? So let's we talk about the dispersed phase. Simply we can say that dispersed phase means similar to solute, and dispersion medium similar to solvent in true solution. Simply to solution. So later on we call dispersed phase in the short form DP and dispersion medium in short form DM. So let's we discuss the classification of colloids. So classification of colloids, which is also known as SOL and which is also known as colloidal solution. At first we talk about classification based on the physical state in dispersed phase and dispersion medium. So here we write at first dispersed phase, then dispersion medium, then nature or name of colloids mostly, name of colloids with example. Name of colloids which is or SOL we call it. Suppose dispersed phase 1, 2, 3, 4, 5, 6. Dispersed phase suppose we suppose solid and solid, and dispersion medium first solid, then liquid, then gas. So solid and solid, dispersed phase is solid and dispersion medium is also solid. So name of the colloids will be solid, SOL, and the best example is the gemstones. gemstones or colored glass also is the best example of solid soul. Solid dispersed phase and liquid dispersion medium. So name of the colloids will be soul or liquid soul and the example of this particular paints, cell fluids, solid and gas. Dispersed phase solid, dispersion medium is gas. So name of the colloids aerosol, and the example is smoke. Most common example is the smokes or unburnt carbon particles, in which unburnt carbon particles, and dust also. Next we talk about the number 4, number 5, number 6. Dispersed phase liquid and dispersion medium liquid, gas and solid. First we take liquid, then gas, then solid. Liquid solid, liquid solid. At first we discuss the solid, liquid, gas. Solid, then liquid, then gas, systematically. So liquid and solid. Dispersed phase liquid, dispersion medium solid. Name of the colloids will be most common gel, and the example of butter, cheese, jelly, so on. Liquid, in liquid, the emulsion. Name of the colloids will be emulsion, and the example will be milk and oil in water. Liquid gas, aerosol, and example is fog, deodorant spray, so on. Next 7, 8 and 9. Gas and gas, and solid, liquid, and gas. Gas and solid, formation of solid soul, rubber, foam or sponge, so which absorb solid. Duster, like for example duster, in which foam is present and there is a small porous structure in which gas is trapped. So this is the example of dispersed phase gas and dispersion medium solid. When the dispersed phase gas and dispersion medium liquid, the example is, name of the colloids is foam. Means froth, jhag, and the example is soap bubbles or froth. Gas, in gas, no colloids form. no colloids form because gas in gas form homogeneous mixture. As we know, because gas in gas form homogeneous mixture. Form homogeneous mixture. So on the basis of particle state in dispersed phase and dispersion medium, we can distinguish easily which type of colloids form when the dispersed phase liquid, dispersion medium solid, when the dispersed phase gas, dispersion medium solid. So in this way you can easily learn all the name of colloids with example. Let's we discuss about next classification on the basis of type of particles. So students, in the next video we will discuss about the classification on the basis of types of particles. That's enough for today.